Okay, so let's check out some of the famous telescopes in the world in each of the different regions of the electromagnetic spectrum. Optical telescopes. Within the optical telescope, the largest one is called the Very Large Telescope. Okay, that's the fanciest name they could think of. So if you're in the business and you go up to someone, you say the VLA telescope, they'll know what you're talking about. Very Large Telescope, VLT. It's VLT. Very Large Telescope. It is in Cerro Paranal, Chile. It has 4 telescopes, each 8.2 meters. They are all reflecting telescopes. Working, but they act in pairs with an effective aperture of 16 meters. So when they act in pairs, what technique is that called? Starts with I. I always like to do a quick review question. Interferometry, yeah. So they basically have 4 telescopes there. 2 of them act in pairs, so you're doubling their aperture. So 8 meters, 8 meters, 16 meters. So they act like a 16-meter telescope. 16 meters is huge, much more than the length of this room, okay? So that's considered the largest effective optical telescope in the world. It's completed in 2002. This was the spot where they first went, Cerro Paranal, Chile, 1991. They noticed the spot, nice mountain. They started building it. They laid the groundwork. 1999, they're starting to build. See, 1, 2, 3, 4. Control room. So, of course, one of the reasons it's good, it's high up in the mountains. You're not going to have city lights, pollution, anything like that. It's going to be very dark. The other good thing is Chile is pretty much close to the equator, right? So it's sort of in the middle of the Earth. If you're in the middle, what does that mean about which stars you can see during the year? You can see every single star in the sky during the course of the year. But you only have 6 months access to them, right, during the night. So a person who was working there, they can study a particular star for 6 months of the year during the evening, okay? Then the next 6 months, they can study the other stars, you know. But they can pretty much see the whole sky. You would be surprised. You would think, who works there? That's boring. Man, I've met people who've gone and worked there and, you know, and then come back. They say, it's full of people. I mean, full of people. They just love to do that. They just live there. You know, they probably have a McDonald's or something. They eat there and whatever. So they work and breathe and live there, you know. Another big one, also Cake 1 and 2, I showed you the picture of earlier. Mauna Kea, Hawaii, has 2 10-meter telescopes. Remember, I said they have segmented mirrors. Each of them has 36 segmented mirrors. And then together they make a 10-meter telescope. They were finished in 1993 and 1996. This is the picture of them. This is a nice view from the top. You see, they're basically above the clouds, okay? And another one, it's not really a big one, but I put it on the list because it is actually here in California. Hale Telescope was built in the early 1900s. It's in Mount Palomar, California, on your way to San Diego if you ever want to stop by there. It's a 5-meter telescope, Mount Palomar. It's called the Hale Telescope. Okay, among the radio telescopes, which ones are some of the big and famous ones? Well, I've showed you the picture of the Arecibo telescope, the largest telescope in the world by far. That's where I said, remember the Bond movie was filmed? 305 meters across, Arecibo, Puerto Rico. Then there's another one. They like this word very large in telescope naming. Very large array is an array of 27 radio dishes working together in Socorro, New Mexico in a Y shape. Very large array. When telescopes are working together and acting as one, we call that what? Interferometry. I'm going to get you to keep saying that, interferometry. How many of them are working together? 27 radio dishes, kind of like in a Y shape. Something like that, let's say. Well, if they're working together, it's going to have the effect of one large telescope that is this big. You see? Y shape. If you connect their signal, you've essentially built a telescope that is huge. A cheap way of doing that, you see? This picture shows you, I think this is a picture of those telescopes, Socorro, New Mexico. You see here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There's a couple more missing like that. You see, they're each big to begin with. You see how they're curved? Parabolic. And then their receivers are at their focal point. There's a receiver there. The one that's even bigger than that, very long baseline array, is an array of 10 radio dishes. It has less dishes than this one. This has 27 dishes. This has only 10 dishes. However, what makes it even better is that each dish is in a different state. I mean, we're not even talking about each one is in New Mexico. They're each in different states, and they're in different countries around the world. And somehow they have connected the signals of all 10 of them. So basically it acts as if it's one telescope that's 9,000 kilometers wide. That's how big, effective aperture of the telescope. Very long baseline array. Okay, within the infrared region. Within the infrared region, you got the first infrared telescope is IRAS. Well, IR stands for infrared. It gave us the first pictures, the first images of the infrared region. The COBE telescope, before becoming a basketball player, he was a telescope. Okay, COBE became important because we sent COBE out with one purpose in mind. According to the Big Bang theory, if the Big Bang truly happened, this explosion happened billions of years ago, the after effects of that explosion should have cooled down by now, and it should have left a remnant there. We should have seen an infrared glow in the infrared region. So the theorists told us, send a spacecraft and let them map out the sky in the infrared. And there should be this glow. And if they see the glow, then the Big Bang really happened. Okay? And lo and behold, they sent the COBE, and the COBE mapped out this infrared part of the sky. You know, remember, infrared means heat. So it was the glow of the Big Bang. So it basically proved the Big Bang theory. SOFIA telescope is kind of interesting because the SOFIA actually is not completely in outer space. It rides in a Boeing airplane and goes around the Earth in the sky. It's an unmanned airplane, and they robotically control it. And the SOFIA rides in that. And then, of course, they bring it down for refueling and stuff once in a while, you know. So they was launched in 2002. The Spitzer telescope, 2003, This one has an interesting orbit. It has the same orbit as the Earth, but trails behind it. It goes around the sun. So as the Earth is going around the sun, the Spitzer goes behind the Earth. Okay? So on the test, I could ask a variety of questions. I could say, which of the following is a infrared telescope? Then you have to know it's Spitzer, COBE, IRAS, Sophia. Which one rides in an airplane, not in the outer space? Sophia. Which one has the similar orbit to the Earth, but trails behind it? Spitzer. You can see here astronomers, they're working on the Spitzer telescope, doing the final touches. Ooh, it's pretty big. And this is the kind of images in the infrared it gives us. Ultraviolet. Ultraviolet telescopes and X-ray telescopes, they're going to map out the hot stuff in the sky. Maybe the supernova explosions, the hot events, the explosive events. The first one was the IUE. The first of this kind was the International Ultraviolet Explorer. I means international. International Ultraviolet Explorer. It went from 1978 to 1990. The most famous one in this category, Hubble Space Telescope. Okay, you probably have all heard of it. It's been functioning since 1990. The Hubble is pretty good because it can also view the optical range. It can also view the infrared range. It could do infrared, it could do ultraviolet, it could do optical. By the way, if we look at this picture, it shows you some of these telescopes, what they look like. They kind of look about the same, usually. This is the Hubble. But they're designed differently, you know. This is the Extreme Ultraviolet Explorer, EUVE. This is the infrared space radio. And then this is the Chandra X-ray telescope. So they do look similar on the outside, but inside the design, completely different. Okay. Okay, next one, X-ray telescope. The first of that kind was the Einstein telescope. Einstein worked from 1978 to 1981. Notice a lot of them started around late 1970s, early 1980s. Before that, we didn't have all these great pictures and stuff. That's when it really took off. Rosat is named after the discoverer of the X-ray. There's a German scientist, Rosat Röntgenstadt, the discoverer of the X-ray. He worked from 1990 to 1998. Beppo SAX was launched in 1996 and observes over a wide range of X-ray frequencies. Chandra. Well, that Chandra I showed you earlier here when I brought this picture up. It's an X-ray facility, was launched in 2000. This one really gives us pictures that compete with the Hubble Space Telescope. Beautiful, beautiful pictures. And gave us pictures which compete with the Hubble Space in their clarity and beauty. Oh, this is the picture from the outside of the Chandra. When we look inside, we see all the design that has to go into it. With X-ray telescopes, what you have to do is gradually guide the X-ray to the focal point. You can't use just one or two mirrors. You see how the surface is parabolic surfaces, hyperboloid surfaces. So the X-ray beams come, and you're kind of gliding them. You are basically coaxing the X-ray to eventually go and make a sharp image over there. You see? So lots of design in this. Engineers work years and years. 4 nested paraboloids, double reflected X-ray beams, 4 nested hyperboloids. Then you get the final picture. Gamma ray. what I'm going to end with now is I'm going to show you a couple minutes, a little slideshow, okay, of the different sorts of pictures that these telescopes give us. Without these telescopes, we wouldn't have these pictures. So this one is Compton Gamma Observatory, 1990 to 2000. And, oops, let's go back. And the last one was the Swift Swift telescope. Both of these are in the gamma ray region. So let's end with a little slideshow. These are some pictures that I've downloaded from online. And then I'll put a little music on the background for you to enjoy. One of the pieces that I like, there's a composer by the name of Gustav Holst. He wrote a piece called The Planets. And on each planet, he has a different song. The one that I love is the Jupiter song. So I'll go to YouTube and I'll put this on. A picture tells 1,000 words, doesn't it? When you see these pictures that they give us. It's beautiful. Wow. I mean, when you see these, you're just left breathless, aren't you? Amazing. Wow. I get goosebumps when I see this, you know. I think our time is up, huh? Okay, have a good weekend, everyone. Study for the test.